What's going on, guys? CZeroMedia here. Well, in the last episode I completely screwed up the cam removal process. This is the cam that came out of the engine, but I was supposed to take it out without removing the cylinder heads. But now the cylinder heads are off, I'm gonna take the heads off the Besnik engine design here in Michigan. So I'm gonna talk to the owner today, learn a little about LS engines and do a little video on that, and also do a shop tour because all my friends take their engines to Besnik engine design, whether it's LS, whether it's Evo, Subaru Motors, they have taken it to Besnik, and every single one of my friends has recommended to check out the shop. So that's what I'm gonna do. I'm gonna load up the cylinder heads in my car and head out to Besnik. You know, one thing I just realized, guys, that I have 3 cars that are 5.7 liter. I got the truck, the Z06 Corvette, and the FD RX7. They all have 5.7 liters. And I have a 2 liter Evo and a 1.3 liter rotary. So I'm becoming more and more American every day. I'm in my 5.7 liter Hemi with my 5.7 liter LS engine head in the back, and I am on my way to Besnik. Alright, what's going on, guys? I'm now at Besnik Engine Design with my buddy Peshko, and we're gonna walk around the shop real quick and figure out what we're gonna do with my head. Let's talk about what you do here. So obviously you're doing a lot of engine work.
Yep, essentially all we do is engine building. We have a pretty wide range of what we do for as far as applications. We don't try to limit ourselves to anything. We deal with LSs, Supras, 4G6
Oh, is that 2J right here?
Yes.
Yeah, I recognize that straight 6.
We have clientele actually all over the world.
Oh, okay.
We get cylinder heads from Australia.
Oh, wow.
This particular engine is a LS build. It's from North Carolina.
Okay.
So we have quite the following so far.
Yeah, that's good. That's good. That's good. Okay,
Yep.
okay.
So this is all Evo.
Yeah, order from here. Let's go. Distance and ARPs. And...
This is actually for David.
Oh.
David's K20.
Oh, okay.
Yep.
So this is a full build.
This is a full build, yep. This is actually a 2-1 D-stroker.
Okay.
4G6 4 block, 4G6 3 head.
Nice. Nice.
Uses the long round setup.
Nice.
And that one over here, this is actually a 4.6 liter dual ride cam Mustang engine. If you look at it on our page, this one had
Mustang build, huh?
Yeah.
4.6, interesting.
So this particular one actually had a valve failure, so we do a lot of head repair work as well.
Sure. I saw a picture of, I don't know what engine it was, but the valve was completely destroyed. Yeah. And I'll put a picture on that. But it was completely destroyed and this guy fixed it up.
So like you can see the after, and then I'll show you the before too.
Yeah, you did some amazing work. So you just kind of weld that in basically? And
then welding and then reshaping by hand, install new valve seats.
Right, right.
There's another super head there.
Yeah. Man, people love 2Js.
Yeah, the Fast and the Furious crowd.
Yeah, that's right.
These ones are actually LS1 heads, LS1 style heads, I should say.
Okay.
Casting number is 317, so they have the larger combustion chamber.
Okay.
A lot of the turbo guys like them.
I see.
So, essentially that's what the CNC program looks like when it's done.
Look at that.
And you can see on the exhaust side as well.
Yeah, beautiful. Yeah, you definitely work on all kinds of stuff here.
Yeah, we try to essentially keep the keep an open platform.
Right, yeah. Yeah, so this shop obviously is located in Michigan, but like he was saying, he gets engines from Australia. So if anybody's interested in shipping your motor here in the States, no problem.
Yeah, we deal with a lot of shipping companies, and we get pretty good deals on that, so we can definitely help you out there.
Okay, all right, cool. Good plan. So the engine in here is supposed to be LS6. It was a crate motor that went in my FD. Okay. If you saw any more in videos, it was basically barely running. I didn't even know what cam was in there, and I pulled out the cam profile and looked it up online. But first I want to confirm that it's LS6 or not anything.
So yeah, the 799 heads, essentially those are the same as the 243 castings.
Okay.
Very, very extremely minor differences, but that is consistent with the LS6 style engine. So
all right.
I would assume it's an LS6.
Okay. That's good.
Step one, check.
So essentially, it looks like you have aftermarket valve springs on here too.
I think the retainers are still stock. I'm not sure.
No, they do not look stock.
No? Oh, wow. Okay.
Yep. So essentially, I like to look here between the valve seats. And occasionally, depending on how the engine was treated and the type of tune that was on it, you'll sometimes see a crack here in the area. This very thin margin between the two valves.
Oh, crack in the head itself.
Right. Yeah.
Okay.
So it's one of the things I like to look for first off.
Yeah, I know the chin on this car is horrible. In fact, it was never chinned. The guy put in the cam and did all this, and then it was never chinned. I didn't even push it past
Really?
3K. Yeah, I was just coasting.
You could tell it's running very rich.
Yeah, spark plugs are like black.
Your new exhaust manifold gasket too.
Oh yeah, definitely. I trust that word.
I'm thinking all new gaskets, Aero-P studs, and everything.
Cool. Do you happen to know the rockers? Do they have the trunnion upgrade or not?
Yeah, I just did them myself.
Awesome.
Because
Cool.
it didn't, so I did that. Yeah.
Okay. Because I've noticed with the factory rockers, they have, the trunnion only moves so far. Actually, it's not a 360-degree rotation.
Right.
So any camshaft that's close to like 600 lift,
Yeah.
that'll actually start to bind the rocker.
Oh wow, really?
Yeah.
I didn't know.
Maybe I can show you an example. These two flat spots here.
Right.
This is a factory LT1 actually, Gen 5. So it only allows it to move so far.
Right.
So if you have a camshaft with very high lift, it'll actually hit that point and start to bind up, and then that's where you get bearing failure and stuff like that. So actually, kind of surprised. I've never seen retainers like this, where the valve tip sits so close to the retainer. It's kind of interesting.
As in like the idea of it?
Yeah, because usually they stick up a little bit like this. And this
wow, okay.
allows adequate clearance around here for the rocker when the rocker starts to sweep for the valve tip.
Right.
So that's pretty interesting.
So the height, you mean?
Correct, yeah.
Okay. Yeah, it's almost, actually it's higher than the tip of the...
Right. I mean, I've never seen that before. So yeah, essentially the CNC program is set up automatically, and what it does is it refaces everything.
Mhm.
So do the deck surface, and do the intake and exhaust surfaces.
Right.
So essentially when you get these heads back, it'll look just like these.
Right. So look at that. You can see that it's CNC. There's these grooves. See that stuff? Going in. So for those of you who don't know the difference between CNC and porting, what's the advantage of doing CNC? It's just more precise and...
Yeah, you get consistency between every port. Naturally, when you hand port ahead, you have to make all the layout marks, make sure every port is consistent.
Okay.
This way, with the CNC program, you can develop one port, copy that program, and just copy and paste essentially.
Right.
So the consistency is the best factor.
Yeah.
One small advantage to CNC heads too is these grooves.
Yeah.
They actually act in a crude word to explain, almost like a roller bearing.
Okay.
So you have this, effectively this air that follows the wall, which is called the boundary layer, and the air will start to tumble between those grooves.
Oh, okay.
So naturally, a CNC ported head and an identical hand ported head, the CNC head will actually flow a little bit
really?
better. Yep.
Oh, interesting. It's like the goalpost kind of.
Exactly, the same concept. You ever see the dimpling that people are doing in cylinders now?
Right.
Essentially the same concept.
Yeah. So what about EVOs? Because I know a lot of you guys are EVO builders. Do you have any programs for EVO? So what can you do with in terms of EVO heads and
Our 4G63 program is in development right now.
Okay.
We're doing finalization on digitizing and setting up the program.
Yeah.
So we spend a lot of time in optimizing both the intake and exhaust ports and finding what the correct valve job is. Actually, we've narrowed it down to the factory valve size being the most optimal.
Really?
Yeah. So we actually lost a little bit of airflow going with oversized valves. It sounds crazy. It does.
That's crazy because I have oversized valve in my EVO.
Yeah. Essentially, what happens is you start to run into a problem where it's like bore shrouding. When you start oversizing the valves,
Yeah.
they get a little bit closer to the bore,
Okay.
and it becomes turbulent in that area.
Okay. So you're restricting flow, creating too much noise, should I say?
Exactly, turbulence. So
Interesting.
yeah, we actually try to stay with the factory valve size in the 4G6
I
reeds.
did not know that either. That's the cam profile, right?
Right.
So not only do you build these LS engines, you know a lot about it. So in my application, I want to make a lot of power in mid-range, probably 3 to 6,000 RPM, something like that, and rev it out as high as possible. So obviously, cam profile is very important, and you know what about LS engines. So what do you think about?
Essentially, I think your duration is pretty on point, 228, 230. I think the lobe separation angle might be a little bit too tight. It's at a 112. So, I mean, obviously, if you can find a better off-the-shelf cam, something with like a 113 LSA, that might be a little bit better.
Okay.
Because obviously, the tighter the LSA, the more effective it is on the high range.
Right.
And it's difficult for for the, I hate to say the average guy, but like the average builder, because the camshaft specs are not generic between every engine. Like we look at here, like a 228, 230. In the Eagle world, that sounds like extremely small.
Yeah, exactly. I'm on 272s in my Eagle.
Right, so. Yeah, exactly. So I just assembled the head.
Yeah.
I can check the spring pressures, open and seat pressure. Okay. And make sure they're all consistent and they're all at a range that that they can handle a larger lift camshaft.
Would beehives hold up to 0.6 whatever lift, or should I go double?
Generically speaking, most beehives for the LS engines are rated to 620, 625 lift.
Okay.
Yeah. Okay. So it still gives you a higher range, but again, too, you don't want to constantly max out the valve spring, because that's when durability and longevity becomes an issue. Right. So.
What about these weird-looking retainers here? Should I replace that? Just that concern here is.
Quite frankly, like I said, I really don't like how the how the tips are sitting down like that. I would actually prefer factory retainers over these.
Really?
Yeah.
How good are the factory retainers?
They're very strong.
Oh wow.
Okay.
That's strong. One thing that surprised me with LS engines, that it's pretty durable stuff. Yeah. They did pretty good job designing it. So like the lifters, the rockers, other than the trunnion kit, issue, it's pretty good design.
Yeah, essentially. The older, the early LS engines, 98, 99, they had their small issues, oiling system issues, but essentially they got it all figured out by like 99, 2000 with the LS6. Yeah. And ever since then, it's just been amazing.
Yeah.
I think GM hit a gold mine with this engine. So.
I think so too, yeah. All right, cool. So what's next with this then? So I'm gonna take it apart.
Yep, essentially what we're going to do is we're going to disassemble them, we're going to get them soda blasted, get all the carbon, do an inspection, make sure there are no cracks, and then start prepping it for CNC.
Okay, sounds good. It's what, like 20 to 40 horsepower or something like that?
This program, depending on the application, you'll gain anywhere from 60 to 100.
Really?
Yes.
Well, that's really nice. Do you recommend a fast intake for LS6? To go from LS6 intake to fast intake? Because there's like a lot of debate on that.
Do you know what your ultimate goals are going to be with the car?
I just want 450 wheel.
Yeah. The factor that I don't like is the price of the fast intake.
Yeah, I know. It's ridiculous.
Right. So for the amount of money that you're going to spend in the gains,
it's bang for buck, right? I think.
Yeah, exactly. Yeah, so
you can spend $1,000 on a 20 horsepower.
Right. Yeah. So the LS6 intake is a very nice design. Right. I think it's the best as far as the factory goes. Right. Factory manifolds go.
Right. How about the throttle body? Just keep that stock as well. Get it ported. Maybe?
Ported, yeah. Typically, that's actually what we do for a lot of our customers. Is
shit, I should just port that in too.
Yeah. Well, we got time.
Yeah. Timing chain. I got LS2 timing chain, but people now tell me I should probably even go with like something even more beefier for track use, like road course use.
Yeah, and then depending if we're going to upgrade springs or not too, like those higher tension springs, they put quite a bit of tension on the valve train and the camshaft. Yeah. So I at the least like to use a Cloyes timing chain, which is a billet gear, crank and cam gear.
Wait, how do you spell that?
Cloyes. Cloyes. Yeah, I could send you a link.
Yeah.
And, so you can use a single roller, that's perfectly fine, those are extremely strong, but they tend to be a little bit tighter as far as tension. If you notice the factory chain, it's got like a little bit of slack to it, moves back and forth. The Cloyes is nice and consistent, nice and tight. So.
Okay. What about the valves? Is this good to go usually for the LS6 stock valves?
For the LS6 valves, I have to take a look at these. Some of them are hollow stem, some of them are sodium filled. So I'll have to see.
Oh wow, so it could be the same LS6, but it could be different.
Right, yeah. So essentially it all depends. I'll have to take them apart and inspect them and see. But the factory valves are actually very reliable. It's not until you get like to the forced induction stage where you want to consider upgrading, you know, to a stainless valve or possibly even an in-canal exhaust valve to handle the heat.
What's going on, guys? I am now finished at Besnik Engine Design and heading home. The shop had awesome amount of engines. He had like 10 ongoing projects right now, including not just LS engines but Evos, 2JZs, BMW engines. He even had B series engines, and I come to find out that the K series that we are putting in the FRS that we are building is gonna be also taken care for by Besnik Engine Design. He was working on engines from Australia, customers from North Carolina, so if you had any engine that needs some attention or upgrades, send it over to Besnik and tell them CZeroMedia sent you, and I'm sure he'll hook you up. The guy knows so much about engines, it's amazing. He used to work for Bosch, so he's not just some random guy who happened to know about engine builds. The shop's name, Besnik Engine Design, really defines the shop, because he not only does he do maintenance, upgrades and porting and so on and so forth, he actually will work with you and try to figure out what will work the best for your engine, for your particular applications. For my track FD, he's gonna choose the right cam for the road course use that I'm building the FD for, and I'll go back to the shop, drop off my throttle body as well, because he can port that out to gain additional 10-20 horsepower. So today I'm just gonna go home, edit some more videos, and I hope I can give you another update on Besnik once the head is good to go. So thanks for watching again, guys. Besnik shop information is in the video description below. Make sure to go check them out, and I hope you enjoyed the video. Make sure to hit me up if you have any questions or comments, and I'll see you in the next video. See you.